I have a hard time accepting the fact that the pollution that we see here in the Don River is as a result of carbon emissions or my SUV. I have a hard time. I also have a hard time accepting the fact that reducing my carbon emissions is actually going to clean this up. The banks of the Don River, very similar to the Humber, we've concreted and essentially turned them into a sewer. And if you look, you can see, the Don Valley Parkway over top here. You can see the rain catch basins up top, and the water comes down the downspout, and of course, there's not a carbon filter, there's nothing on the end, it just goes right into the Don River. I mean, I guess, is it too far gone and we've just given up on the Don? This is like, in the last century, everybody in the city of Toronto's been on a huge bender drinking. And this is the result of that 100 years of drunkenness. And this is what we've got to deal with. And now we're hungover, the party's over, and we gotta clean this mess up, folks.
This program is brought to you in part by RBC.
For all your environmental solutions, Hazmat Management and Solid Waste and Recycling magazines, the Canadian publications that supply industry and municipal managers with all the environmental information necessary to stay on top of this rapidly evolving industry.
This week on Going Green for Green, we're going to recap some of the previous episodes and try and explain the reasons behind the topics that we have covered so far. In our first episode, we discussed brownfields. The term brownfield is kind of self-explanatory. It is basically land that has been contaminated by industry that previously operated on the site. Brownfields are important because the contaminants in the ground can travel through groundwater and leach into our lakes, rivers, and streams. Remediation techniques and technologies have come so far that we can now fix and remediate sites that 20 years ago were considered impossible to clean. If we want to save our lakes, rivers, and streams, remediating brownfields is a huge part of the solution.
Basically, brownfield development is it's kind of an unmined jewel, I guess. And the problem with it in the past is that the remediation of the site wasn't worth the value of the site. So the government a few years back put in a program that they would give you a tax incentive to actually clean the site. We've done a number of small brownfield development. I have property that we've done bioremediation with microbes, which works in certain instances.
And those microbes actually, it's like microscopic bugs.
Yeah, well, these microbes, they can't go. They're not like a bloodhound. They don't go find oil. These are very, very small microscopic organisms. So you basically drill a well and you put your microbes in, and you'd follow the groundwater delineations.
So the microbes actually travel through the groundwater,
yeah,
and then basically eat the waste.
They digest and convert the hydrocarbons into a non-toxic form. So the problem is,
and a hydrocarbon would be like, if
gasoline,
right? There's corner gas stations that had the underground oil tanks all over the city of Toronto, all over the province for that matter. They sit undeveloped, and basically, you're telling me that we can inject microscopic bugs that would eat those contaminants.
Yeah. The problem with that is that
amazing stuff.
Well, it's amazing. It's sort of like it's not as amazing as it sounds, because it only works well with very, very specific types of soils. It wouldn't work well if you're in southeastern Ontario, where we have a lot of St. Lawrence clay. If you have contaminated clay, how are you going to push water through it?
Right.
It doesn't. That's the nature of clay, right? It prevents water movement. So if you have contaminated soils, you're never going to be able to push microbes through it. So you can use other technologies. You can use passivation, which is a very interesting technology, using hydrogen peroxide. You can do the traditional dig and dump, where you dig the material up and send it to landfill, and use it as cover. You can also bioremediate it by moving it and putting it in a system like the Gore system and putting air through it, and using a microbe and continually turning it. Every site is specific, Michael. For instance, you have a site that is where they used to make batteries, for instance. You have a lot of lead contamination. Lead is a heavy metal. It's been designated as a dangerous substance in terms of human beings and plant and animals. And how do you remove a heavy metal from a soil? People have this misconception that heavy metals can disappear. They can't. They just change forms. So you need to put a process in, whether it's on site, where it's a little bit easier in terms of regulation to treat on site, but it's more difficult because you got to bring all the technology to the site, and you may not have the site size to be able to deploy the technology that you need. Or you take the material and you bring it to a processing facility that can treat a lot of that waste and then reapply it.
In episode 2, we discussed organics, and we looked at the two types of organic processing currently in play. 1, anaerobic digestion, and 2, aerobic digestion, which is compost. The City of Toronto currently operates an anaerobic digestion facility which can make energy from your green bin food waste.
We're here at the tipping room floor at the Organics Treatment Facility, CCI's facility in Toronto, and the odor is really overwhelming. And you just get a sense of how important odor management is. Later on we're going to be looking at the biofilter, how this odor is dealt with, and how this facility operates with just really what is, one complaint a year during its operation. It's pretty amazing. Anyway, I got to get out of here.
This facility can process about 40,000 tons per year of the City of Toronto green bin waste. To put that in perspective, that's the equivalent of about 160,000 homes of the 510,000 single-family homes that are implemented with the green bin program in the city. So the waste gets dropped at the tip floor and then it gets loaded onto an enclosed conveyor. We can enclose the conveyors to manage odors. And you can see in here now that the waste is being loaded into the pulper. So after the pulper's gone through its routine, we pump off the organic pulp here in this component. And at the same time, we're also removing the heavy fraction, the glass, the household batteries, through this sieve trap system here. This pulp then goes over to a degritting system to remove the fine grit before it's sent to the digester. So once that pulp has spent its time in the digester, typically from 14 to 21 days, it's then removed and it's sent to these dewatering presses where the liquids are squeezed from it to create a solid. So once the digestate out of the digester has been put through those presses to dewater it, the liquids are treated and returned to the sewer, and the solids end up in this trailer here to be taken to make a final compost product. So our company developed 2 facilities here in Ontario. We're here at one today, the City of Toronto Dufferin Organics processing facility. And within this facility, there is a process implemented called the BTA process. That's the technology that our company has the rights for here in North America. And there's 2 major components to the process. In the building here, what you'll see is the first step, which is wet pretreatment. So when the city collects all of our green bin waste, it's delivered with a truck into that facility, and that's where the contaminants are removed and where the remaining organic fraction is pulped and created into a slurry. That slurry is then pumped off and put into this tank. This is actually the digester, as we mentioned earlier, works like our bodies and digesting our food. Within that tank, the organics are broken down into those 3 components: solids, liquids, and gases. The gas, as you can see, is captured and it's immediately available to create renewable energy. And that can take multiple forms. That could be cogening the gas that's created to create heat and electricity. That gas can also be used to create a high-grade natural gas that can actually be put in the pipelines. The other alternative is to also take that gas and make a liquid fuel. In the case of City of Toronto, the potential to power the municipal vehicle fleet using the waste from the curbs that we all put out. Several challenges when it comes to the diversion and processing of organics from a municipal waste stream. The fact that it's highly liquid requires different processing methods, and the fact that there will be inert contamination in the waste stream, irrespective of how well we do it at the curb and in our homes. Those are contaminants that will still need to be managed. You can see a meat wrapping, you can see a can, a household battery. So it's very important to remove those contaminants. In our case, we do that up front so that we can maintain the downstream product quality in both biogas and the solids, which are typically turned into a compost product.